Hello students. 8a-2 is key attributes of quadratic functions. Now that we know how to graph quadratic functions, we're going to look at parabolas and we're going to dissect a lot about parabolas and see if we can figure out all the little key intricate details that you need to know about parabolas. Okay? So, the first thing, it says symmetry and vertices. Parabolas have a geometric property called symmetry. The vertical line that divides the parabola in half is called the axis of symmetry. Now, we've got a parabola down here. You can tell that there's a line that can cut that slab in half. Okay? The axis of symmetry contains the vertex. The vertex is the highest or lowest point on the parabola. And that vertex is always found on the axis of symmetry. Just like I said right there. Okay, so the axis of symmetry, let's look at some details about that. For a parabola, y equals ax squared plus bx plus c, which is standard form for a parabola, where a doesn't equal 0, the line x equals the negative of b over 2a is the axis of symmetry. So again, we know it's a line because it starts with x, and it's not squared, so it's a line. And if it's x equals some number, then that means it's a vertical line, so that vertical line is going to be our axis of symmetry. So a way to find that, what number is the axis of symmetry, you do negative b over 2a. So for example, let's look at an example over here. It says x squared plus 2x plus 5 is our quadratic equation, and we need to find the axis of symmetry. So we know x equals the negative of b over 2a, which equals, b in this case is 2, so negative 2 over 2 times a in this case is 1, so it's negative 2 over 2, which equals negative 1. So the axis of symmetry is x equals negative 1. Now here's the most important thing that you're going to learn in this video. The equation of the axis of symmetry must be written as x equals negative 1. If you don't write it as an equation, it will be wrong. Because if it's not written as an equation, it's not a line, and the axis of symmetry must be a line. So make sure that your axis of symmetry always starts with x equals. Okay? So here is the axis of symmetry, x equals negative 1. Now, let's look at this example, and we're going to find lots of other things about this parabola. Okay, so first of all, it says write the equation of the axis of symmetry. We're using 2x squared plus 4x plus 1. And y equals 2x squared plus 4x plus 1, a equals 2, and b equals 4. Okay, a, b, c. We don't need c for the axis of symmetry, we just need a and b. So to find the axis of symmetry, it's the negative of b over 2a, which equals the negative of 4 over 2 times 2. And so it's negative 4 over 4, which equals negative 1. So the axis of symmetry is x equals negative 1. It's not always x equals negative 1, just happens to be that. Okay? So now that we know the axis of symmetry, we can actually use that x to find the vertex. Okay? So to find the coordinates of the vertex. And the way we do that is plug in x to find y. So I'm going to do just that. X equals negative 1. That's my axis of symmetry, but it's also the first number in my vertex. Negative 1 comma something. So we're going to do y equals 2x squared plus 4x plus 1 and plug in negative 1 for all the x's. Y equals 2. Here's a trick. Remember, because x is negative, we're going to put it in parentheses. Negative 1 squared plus 4 times negative 1 plus 1. We know that negative 1 squared is just 1, and 1 times 2 is 2. 4 times negative 1 is negative 4 plus 1. So y equals 2 minus 4 is negative 2 plus 1 is negative 1. So my axis of symmetry is, my vertex is negative 1 comma negative 1. And you can see that right here. So that is the lowest point on my graph because a is positive. Okay? So now, is the vertex a maximum or a minimum? Well, we just said that. It's a minimum because it's the lowest point on the graph. Everything else is above it. Now, what is the minimum number? It is negative 1. So the minimum for this is negative 1 because that's the lowest value on the y not axis, but in the y portion of the ordered pair. So the y value is always going to be my minimum or maximum number. The y value of the vertex. I should write that. Okay. Now, identify the y-intercept. Y-intercept hasn't changed. It's where the parabola crosses the y-axis. Sometimes it's visible, sometimes it's not. So we look to see there's the y-axis, that's where it crosses. So this is 1. So the y-intercept, y-int equals 1. And that's how we would write it, y-int. There's no, well, there is kind of a happy letter. It's actually C, if you didn't know that, if you haven't figured that out yet from the other notes. The C value is always the y-intercept this year. Okay? So, well, we don't put C equals 1. We always identify it as the y-intercept as -1. And then they graphed, it's already graphed for us. But we could graph the vertex, -1, comma, -1. We could graph the y-intercept. And because we know the y-intercept and we know it's symmetrical, then we can also graph this point right here. And we've already got 3 points. So then we could keep going and add just 2 more. So when we are looking for key attributes, this is something you're going to have to be able to identify is you have to know how to find the vertex. You have to know how to find the axis of symmetry. You have to know how to identify the y-intercept and identify the minimum or maximum. All of those things. It's a lot. But once you get a hang of it, they'll be easy to find. So let's look down here at the bottom and let's do a couple together. Okay? So consider each equation. Determine whether the function has a maximum or minimum. That's by looking at A. Okay? State the maximum or minimum value, the equation of the axis of symmetry, the domain and the range of the function, the y-intercept, and the solutions. And then graph the function. Dang! That's a lot. But it's going to go quickly. Okay? So I'm going to first identify if it's a maximum or minimum. Because A is positive, I know that it's a minimum. And I'm just going to put min, and we'll figure out what that minimum value is. So now we need to find the equation for the axis of symmetry. So A equals 1 and B is 0. If B equals 0, then let's figure that out. X equals the negative of B over 2A, which equals the negative of 0 over 2 times 1, and 0 over 2 equals 0, so the axis of symmetry is x equals 0, which is the y-axis. Okay, so I'm still going to, usually we put a dash line, but since it is the y-axis, it's pretty hard to see. Okay, so that is my equation for the axis of symmetry. And now I need to use that, and I'm going to find the vertex. So let's plug in 0 for x. 0 squared is 0 plus 3 is 3. So the y value equals 3. So my vertex is 0, 3. 0, 1, 2, 3. There we go. Okay. So I have done the axis of symmetry, domain, and range. Well, now I can do the minimum value. I know that the minimum equals 3. Now, the domain and range. The domain is all real numbers. Negative infinity is less than 0, which is less than infinity. The range, we know it's going to open upward because A is positive. The range is y is greater than or equal to 3. Okay? And in this case, the y-intercept is also 3 because the axis of symmetry is the y-axis. So the y-intercept equals 3 also. So we have identified everything that we are supposed to identify, and now we're going to graph the function. So we're going to get our calculator and turn it on, and I've already got a screen open. So y equals x squared plus 3, enter. Control T to find my table because I need some more points. I'm going to do 0, 3. Let's do 1, 4 and negative 1, 4. And then we'll do 2, 7 and negative 2, 7. And there we have our smooth curve with arrows. Okay, so we have identified everything that we needed to identify, and then we ended up graphing the function. So we have the equation of the axis of symmetry, we have the y value, which creates a vertex, the minimum value, the domain, the range, and the y-intercept. Okay, so let's do another one. Let's do number 3. Okay, so we got y equals x squared plus 2x plus 3. The first thing we're going to do is we know it's going to be a minimum value because a is positive. We'll find that out in a minute. Now we're going to find our axis of symmetry, x equals negative b over 2a, which equals negative 2 over 2 times 1, which equals negative 1. So x equals negative 1. And now to find the y value, we're going to plug in that negative 1 for all those x's. So it's going to be negative 1 squared plus 2 times negative 1 plus 3. So that's going to be 1 minus 2 plus 3. 1 minus 2 is negative 1 plus 3 is positive 2. So the y equals 2. So my vertex is going to be negative 1, comma 2. So negative 1, comma 1, 2 is my vertex. You with me so far? So we've got our vertex. Now we know our minimum value is 2. We know our domain is negative infinity is less than 0 is less than infinity. And we know our range, y is greater than or equal to positive 2, because that's the y value of the vertex. And the last thing we need now is the y-intercept. We don't know that yet, so let's use our calculator to graph this puppy. Whoops, I didn't want that. Let's go back home and do 1, no. And we're going to graph, x squared plus 2x plus 3. So we go x squared plus 2x plus 3. And we hit enter. And we do Control T for our table. And so we're going to go up a little bit. We know that our vertex is negative 1, 2, so we can find that on the table. And then we're going to do negative 2, comma 3. 1, 2, 3, which means it's 0, comma 3. Oh yeah, because c equals 3, that's my y-intercept. Duh. Y-int equals 3. And then we're going to do negative 3, positive 6, and then 1, positive 6. Notice how we can use that axis of symmetry. Uh-oh, we never graphed our axis of symmetry. We need to put that in there. It's always important. Graph, graph, and that's how we identify the key attributes of our quadratic function. Now sometimes you'll be given a quadratic function that's already there, similar to this one, and you'll have to identify the key attributes, but you can just look for where the axis of symmetry is that splits it in half, see where the y-intercept is, find, the vertex in each of those points just from looking at the parabola. But what I'd like for you to do is to do number 2 down here by yourself and with your calculator, obviously, and then do that before you come to Math Workshop.